Hello, this is Brother Cromer from the Math Department. This is a continuation of ANOVA, which is inference for several means. We left off with this problem where Emmons and McCullough had 192 graduates and divided up into three groups: gratitude, hassles, and events. And each of these groups recorded 5 events. Gratitude was 5 things that were grateful for, hassles 5 irritants, and the events 5 things that occurred in the past week that had an impact. But then I also recorded the level of satisfaction. But the goal for this is to see, is the mean level of satisfaction different between the groups? So the null hypothesis for ANOVA is that all the means are equal. And the alternative is that one or more of the means differ than the others. So steps 2, 3, and 4 we get from output from either SPSS or Excel. So I have an example of SPSS output, where step 2, this is the degrees of, this is the test statistic, or F test statistic. This is the degrees of freedom. Now we have two levels of degrees of freedom. The between group degrees of freedom, which is 2, and generally speaking, it's the number of groups minus 1. There's 3 groups minus 1, so it's 2. And then within group variation. So in this case, generally speaking, it's the degrees of freedom for this is the total sample size combined from all of the groups minus the number of groups, and so in this case it's 189. Both of those have to be listed for step 3. For step 4, for the p-value, this is the number right here under what it says SIG for SIG for SPSS. So in this case, the p-value is 0.019. And so what we do is we compare the p-value to our level of significance, which is 0.05. And since this p-value, 0.019, is less than 0.05, we reject the null hypothesis. And then the last step, we say we have sufficient evidence to say that at least one mean happiness score is different. Okay, or we can say we have sufficient evidence to say that one or more of the means differ than the others. Either way would be fine. Okay. Now what you can do is that you can stop the video and try this out to see if you can do it. This was in the online textbook where, and we'll go through this problem here. Nike, a company that makes sporting goods, includes shoes, funded a study to compare 5 soccer shoe designs. The objective of the research was to determine if there was a difference in the mean accuracy soccer players achieve using different Nike shoe designs. As part of the research, they asked trained soccer players to kick the ball at a target. The target was placed 115 centimeters above the ground at a distance of 10 meters from the players. Using electronic equipment, the researchers recorded the distance from the center of the target to the point of where the ball hit. The objective of the research was to assess if footwear could affect the accuracy of a soccer player. Subjects wore 5 different soccer shoes, and for one treatment they kicked the ball in stocking feet. They used a level significance of alpha equal to 0.10. So what you can do is the link to it is in the online textbook. You can stop the video and try to see if you can do the 6 steps on your own. Okay, so here are the answers to this. The step 1 is state the known alternative hypothesis. The null is that all the means are equal, and the alternative is one or more of the means differ than the others. So steps 2, 3, and 4 we can get from our output. And so I have an example of SPSS output here, where so if I go down here, here's the ANOVA table. Here's step number 2. Here's our test statistic for the F test statistic. Here are my 2 degrees of freedom, 5 and 114. Now my p-value is 0.081. Okay? So since our p-value is less than alpha, which is 0.10, we would reject the null hypothesis. And so we have sufficient evidence to say that at least one mean distance from center of target is different across the 5 different types of footwear. You can write it like that, or you can say we have sufficient evidence that one or more of the means differs than the others. Either one would be acceptable. Okay. So then what I'd like to do is, for the last part of the video, is talk about checking requirements in descriptive statistics. So before doing ANOVA, the requirements to check is, first of all, the samples are from a simple random sample. The samples are independent. The populations have the same variances. And how we check that, we can check to see if the largest standard deviation is no more than 2 times the smallest standard deviation. Okay? And then I'll go through an example of that in just a sec. And then the last requirement is that the data are normally distributed, so we do use QQ plots. So that we can assume the sampling distributions or the distribution of sample means are normal. Okay? So here are some examples. So I'm going to focus in on these last 2 here to check to see if the variances are the same and the data are normally distributed. So I'm going to go to some SPSS output, and this is similar to what you would see in Excel. So here are, if I go to some output here where I look at, for instance, events, the three different groups for the first problem where we have the events group, the grateful group, and the hassle group, we can calculate the standard deviation for each of these groups. And so what we do is we can take the largest standard deviation, which is 0.9443, divided by the smallest standard deviation, which is 0.8320. And if that ratio is less than 2, then we can assume the variances are equal. And so just by eyeballing it, you can, or another way to look at it is you can see, is this standard deviation no more than 2 times this standard deviation? And by eyeballing it, we can see that the requirement is met, and we are good, so the ratio would be less than 2. That's the way of checking equal variances. With the QQ plots, here's an example of 3 QQ plots down here for the events group. That looks fairly normally distributed. The grateful group as well as the hassles group. And they all look pretty good in terms of it being normally distributed. The sample sizes are all fairly large, so we can use the central limit theorem to say that the distribution of sample means is normal. Yet the one last thing to mention in this video is the descriptive statistics. And the descriptive statistics, the numericals, we want the sample size, the sample mean, and the standard deviation for all the samples. And for the graph, we can either do a histogram or a box plot for all groups. Okay? So here are some examples of where with the hassles, or the 3 groups, we have the hassles, the grateful group, and the events group. We can get the sample size, the means, the standard deviations from all these groups. We can also get histograms, and I have an example of both the box plots, where the side-by-side box plots, we can compare box plots. But also we can look at histograms as well. And if you look at it here, it looks like that the hassles group, it's a narrower or smaller spread. And in this one here, this looks to be right skewed. And this one you can almost argue is bell-shaped. But this is what you would look at, and then you would describe in terms of what you would see in terms of comparing the distributions. You can compare the shapes, you can compare the center of the distributions, and you can compare the spreads of the distributions using the histograms as well as the box plots. And that concludes the videos dealing with inference for several means and dealing with the ANOVA procedure.